Hey everybody, this is our last, or at least my last video for ionic compounds. We're going to look at how to write the formulas of these things. All right, so in the last one, we looked at how to write some of the names of these ionic compounds, and we're looking at formulas. So again, we're just going to get right into it. I don't know what's easier, writing the names of the formulas. All right, I think the formulas are easier. I like writing the formulas a little more than writing the names because it's easier. I think it's shorter to write the formulas. So again, we got three examples: potassium sulfide, ammonium perchlorate, and copper 2 phosphite. Those are our three examples. Again, cation is the beginning. I've got that in red. Anion is the second part of the ionic compound, and that for me is in green here. So again, for the formulas, what I tend to do is separate the cation and the anion. And ionic compounds are all about, well, ions. They're all about balancing the ion charges in your compound. Once the charges are balanced, you can write the formula. Now, we did a long version of this when we showed electrons transferring, but there's a shorter, easier version that we can do, which we're going to look at now. And again, maybe you caught on to this earlier. So let's do our first, actually let's do all three. We're going to do the cation for all three at the beginning, then we'll do the anions, and then we'll put them together to get the formula. So potassium. So you can either look at one of two things for the charge of the potassium ion. You can look at the polyatomic sheet, or you could look at the periodic table. Well, the polyatomic sheet, if I take a look, it only has one cation, ammonium. Well, that actually helps us with the second example, because ammonium's formula and charge is NH4 with a 1 plus. So there's ammonium. So the formula and charge of ammonium is NH4. I'm going to write 1 plus. Potassium must be on the periodic table. Whoops. So let's take a look up here. There's potassium, and there's our charge. All right, you eventually might memorize these charges because you're going to use them so often, but that's potassium's charge. It's K. Don't write P. Oh, please don't do that. P is phosphorus, all right, not potassium. Thanks. All right, so potassium is K with a 1 plus. Copper 2. So first of all, copper is not CO. Gosh, no, CO is cobalt. Cu is copper. And if you're like, wait a second, what's copper's charge? Mr. C, what are you doing to me? Well, psst, it tells you right there. There it is. Transition metals are so straightforward when it comes to formula writing because the charge is right there. There it is. It's a 2 plus. So copper's a 2 plus. No, it does not mean that there are two coppers in the formula. It never means that. It never has meant that. It means that the copper's charge is a +2. It tells you. It's like, psst, this is what I want for Christmas and my birthday. So you get those things. Or maybe not. I don't know. Copper's a 2 plus. There we go. Okay, done. Now we got to look at the anion. Sulfide, perchlorate, phosphate. Phosphate. Sulfide. Well, it ends in "ide", and it's sulfide. On the polyatomic ion sheet, there's only two polyatomics that end in "ide" that we look at. One is hydroxide, which is OH minus, and that's not sulfide. And the other one is cyanide, which is way down here. But that's not sulfide either. And if you're like, Mr. C, you misspelled sulfite. Nope, sulfite is different. All right, so you have to, when you're writing the formulas and the names, you have to be very particular about the spelling. All right, or if you're handwriting, you gotta be clear with your handwriting. All right, sulfite is different than sulfide with a D or with a T. So I'm dealing with sulfide. And what we talked about earlier is that monatomic anions on the periodic table end in "ide" for those particular nonmetals. So sulfur would be sulfide, 2 minus charge. So there we go. Sulfide is S with a 2 minus. Cool. Perchlorate. Well, right away we see 8, and so immediately it has to be on the polyatomic ion sheet. Immediately. So we're going to head right to this guy and look for perchlorate. No, it's not percolate. That's when you make coffee. Perchlorate's different, and there it is. They're all kind of hiding on the polyatomic sheet. Take your time and find them. Don't be like, I can't find it. You can find it. Take your time, okay? Time is on our side. There it is. ClO4. So that means there's one chlorine atom and 4 oxygen atoms all clumped together in this ion. It's kind of like your hand. Your hand has 4 fingers and 1 thumb. There we go. 4 fingers, 1 thumb, perchlorate. All right. So it's ClO4 with a 1- charge. That's perchlorate. Phosphite. It's phosphite with a T, not phosphide. So you're just looking for that exact ion on the polyatomic sheet because it ends in ite. So it's right here. There it is, phosphite. It's like phos is fighting. PO3 with a 3-. Again, the charge is -3, and there's 3 oxygen atoms bonded to that phosphorus in that ion. So it's going to be PO3 with a 3-. Cool. All right. So those are all of our charges of our ions. Now we got to write the formulas. Formulas are all about balancing charges out, okay? So you're not just going to write Ks because the charges don't balance out. You need to have the same amount of pluses and minuses. The cations and the anions, their charges need to cancel each other, all right? So right away we look at this, +1, -2. It doesn't cancel. If it does cancel, it'll be plus and minus the same number. Oh, look, like the second example. We'll hit that up in a minute. You need another potassium to balance out the charges. All right, just think about the very simple math. If you have -2 and +1, they don't cancel each other. You need another potassium ion. So all of a sudden, if you check out these little pictures, we have how many potassium ions? 2. How many sulfide ions? 1. Your formula is K2S. 2 potassiums, 1 sulfide. There you go. No charges included in the formula, no nothing. It's just K2S. That is potassium sulfide. Sweet. Next one, ammonium perchlorate. Ooh, +1, -1. Nice. They already cancel each other out. So this formula is literally just cation anion. NH4, ClO4. Done. I know it might seem weird. Yeah, well, wait, what about NH4, ClO4? It's fine, because if you're looking at this formula, you would be able to pick out ammonium right there, and this is the perchlorate. So you'd be able to write the name given this formula. So ammonium perchlorate, NH4, ClO4. No parentheses, no Roman numerals, no nothing like that. All right. So copper 2 phosphite, last one. So if you check out the charges of this Cu2 plus and the phosphite ion, they're not equal and opposite. So this one tends to be some of the the more challenging ones for the formulas, but just take your time. You need to balance the charges out. So I usually just keep on adding cations and anions until the charges even out. So copper 2 plus, we have 4 positives now and 3 minuses. This is not going to work. So add another one. Again, you're going to keep on adding until the charges balance out. 6 minuses. Oops, sorry. 6 minuses, 4 pluses. Doesn't work. Let's finish it off and you'll see what's going on here. Look at the charges. 6 positives and 6 minuses. That's perfect. So when you write the formula, you need to show how many of each ion you have. So I'm going to start with the cation. I'm going to do Cu. I have 3 of them. So Cu3, just like up here, you did K2S, 2 potassiums. So 3 coppers. But now I have 2 of the phosphites. So I'm going to write PO3 because that's phosphite, but I need to show I have 2 of them. That's where these parentheses come into play, because you need to show that you have 2 of these phosphite ions, and that little subscript outside of the parentheses tells you that. And there you go. And you can kind of see a little shortcut here. Oh, look, copper's at 2 plus, and you need 2 phosphites. Phosphite's at 3 minus, and you need 3 coppers. Interesting how that works. It's always going to work that way with a 2-3 or a 3-2. But you'll pick up on that pattern as you go. Okay, that's it.